The concept of levels of measurement is critical to this class and statistics in general. All of the decisions you make in terms of how you analyze the data, what pieces of information are relevant, what statistics are reported and analyzed, what measures and tests you perform, all rest on understanding this concept. First, we're going to review the basics of the idea, and in the lab, you'll have the opportunity to gain hands-on practical experience with this concept. By the end of the course, most students have a firm grasp of the concept and are able to make appropriate choices. Understanding levels of measurement rests on thinking about several different component parts of each variable simultaneously. The variable is what we are measuring, comparing, or using to help us explain or understand the population. Variables have certain features. Some simply distinguish categories. In other cases, categories denote more or less of something, weaker or stronger feelings, greater or lesser interest, and in some cases, the categories are exactly measurable. Each of these situations denotes a different level of measurement of variables. In other words, the types of statistics and tests that you would use when comparing self-reports of ethnic identity and political party identification are different than analyzing self-reports of ethnic identity and household income. Political party is something that is grouped but has no numeric value. It isn't quantified, while household income is a dollar amount or a numeric indicator. So when you are attempting to determine the level of measurement of a variable, you are asking, is it grouped? Is it ranked? Is it numeric? There are 4 levels of measurement of variables: nominal, ordinal, interval, and ratio. For the purpose of this class, interval and ratio variables will operate similarly and will be referred to as either IR, interval ratio, or scale variables. Nominal variables are those that have no numeric value and no ranking or ordering to the answer categories. These are very common in social science research. Typical examples of nominal variables are things like gender, race, sexual orientation, religious affiliation, political party identification, and so forth. In all of these examples, the answer categories to the question posed are not higher or lower in relation to another. There is no stronger or weaker, more agreement or less agreement, and it is non-numeric. Ordinal variables are those in which the categories have no numeric value but are rank ordered consistently. For example, the variable highest degree earned, which measures academic credentials, is an ordinal variable. An associate's degree is more education than a high school diploma and less education than a Bachelor of Arts or Sciences, a 4-year degree. However, we cannot quantify exactly how much more or less education it is. Anything that is answer categories that range along a scale of some kind that is more or less, more opinion, less opinion, is usually ordinal. For example, level of support from support to oppose, level of agreement, strongly disagree, disagree, neutral, agree, strongly agree, level of commitment, weak, moderate, strong. As answer categories, those would imply that the variable is ordinal. Moreover, any variable that denotes a range from more of one thing to less of that thing, such as lighter to darker, is also ordinal. Interval variables are numeric. They are numbers. However, the 0 point is arbitrary, meaning it isn't really the absence of something or wouldn't exist. For example, temperature measured in Fahrenheit or Celsius is an interval variable. 0 is not the absence of temperature, rather it is simply a point on the scale. Ratio variables are numbers, like interval variables, but with the added condition that 0 is really the absence of. For example, income is a ratio variable. It's a number, and 0 really means the absence of any remuneration or payment for services. For the purposes of this class, interval and ratio level variables will be referred to as interval ratio level, IR variables, or scale variables, as the distinction doesn't matter at this level. What are typical scale variables in the social sciences? Household income, number of children, age, years of school completed are all examples. So how do you determine the level of measurement of a variable? First, consider the answer categories one has to choose from. Are there categories? Are they ranked? Numeric? If they are in numeric categories, are the categories of equal width? For example, age categories of 10 years each. If the answers are non-numeric, are the categories moving from something greater or lesser? Is there any kind of natural order or ranking to the answer choices? This slide demonstrates a simple decision tree for nominal, ordinal, and interval ratio level variables. If it's numeric, it's interval ratio or scale. If it's not numeric, is there any kind of ordering? If not, then the variable is nominal. If there is, then it's ordinal. There are some cases that are more difficult to classify or determine. Dichotomous variables are one such problem. Variables with only two relevant answer categories, such as yes, no, present, absent, and so forth, are often treated as either nominal or ordinal. Or rather, one should say, the distinction between nominal and ordinal variables disappears with dichotomous variables. Numeric categories of equal width are often treated as numbers in statistical analysis, though each category actually reflects a set of values. Keep in mind that interval ratio, scale, level data can be recoded into ordinal categories. For example, many students have been interested in comparing younger and older adults, so they have recoded age to reflect ordinal categories. We might also create some scales to measure attitudes. We might recode a numeric scale into answer categories such as low, medium, or high. One can recode from a more detailed level of measurement to a less detailed one, but one can never recode in the other direction, from a less detailed level of measurement to a more detailed. In other words, I can aggregate numbers into categories, but I cannot disaggregate categories back into numbers. Another set of relevant distinctions made about variables that relates to level of measurement is, are they categorical, discrete, or continuous? Categorical refers to variables that are nominal or ordinal. The answer categories fall into categories, hence the name categorical. Discrete versus continuous variables distinguishes between interval ratio level data that might be expressed as whole numbers versus categories that can be expressed as fractions. For example, numbers of children is a discrete variable. You cannot have half a child. By contrast, height is a continuous variable. I can express your height in inches, quarters of an inch, and so forth. This slide provides a handy guide for distinguishing between categorical, discrete, and continuous data. The appropriate statistics, tests, and graphic displays to help audiences understand data is dependent on the level of measurement of the variables involved. Levels of measurement can be a little confusing at first. It is crucial that you understand this concept, so if you need extra help, please don't hesitate to ask. I'm happy to assist you in lab or during my office hours. If you can't attend my office hours, we can find another time to meet. Please don't forget to take the comprehension quiz.